Hello, ma'am. We'll start, ma'am.
Yes.
Yeah, okay. I'll go from the beginning. Hello, everyone. Good evening, and thank you for joining us today. And I welcome you all to our webinar on computing and signal processing in IoT applications, organized by Institute of Engineering Research and Publication. Since our speaker of the day has already joined us, I'd like to introduce her. And good evening, ma'am, and thank you for joining us today. So before we proceed further, I'd like to introduce ma'am. So this is Miss P. BINDU SWETHA, who is an assistant professor currently of Electronics and Communication. And to read a few words about ma'am, she has completed a bachelor's degree in ECE from JNTU Hyderabad, 2006, and post-graduation in MTech in VLSI design during 2012, and now pursuing PhD in the field of microelectronics and VLSI design from Satyabama Institute of Science and Technology, Chennai. Ma'am has published a good number of papers in reputed journals like Springer, Scopus Index, WOS conferences, and also 4 textbooks in the field of digital electronics, digital signal processing, VLSI with Verilog HDL concepts, book chapter publication international academic publishers, and also 6 patent publications in IPI India. Currently 1 textbook publication with IOR International Press, and she's also acting as an editor on COVID-19 and an author on electronics. She has successfully completed 45 plus online courses through NPTEL, IIT India, Udemy, Publons Academy, a Clarivate Analytics company, and Springer Research Academy, a WOS group. She received Young Researcher Award from ESN Research Group, conducted various speaker session webinars through virtual mode, acted as a keynote speaker, and also as a session chair in ICMRI 2020 at Chennai, India. Ma'am has served as an advisory board member on various conferences organized by IFERP, received keynote speaker session from IFERP India as well. Her social interests include associating continuously from last 5 years in mentoring to economically backward students. She has a strong passion in educating girl children and who are pursuing their education through scholarships by providing necessary requirements. An active member of MISCE, AMIE, MUACEE, MIAENG, and professional member in IFERP. She has supervised several academic UG and PG projects, conducted technical symposiums, workshops, TRIS 2014 IIT Delhi as a coordinator. So currently, ma'am, like I've said before, is an assistant professor, a researcher, and innovator of EC and Innovation Cell faculty in charge of Pullaiah College of Engineering and Technology. So I welcome you, ma'am, for today's session. Would you like to share a few words with our attendees today?
Yes, thank you so much.
Yeah.
Thank you so much, dear.
Yeah. Welcome, ma'am. So without further delay, we can proceed with our presentation. Ma'am, you may begin right now, ma'am.
Yes, thank you so much.
Yeah, you're welcome.
Thank you so much for inviting me. Today's topic is computing and signal processing in IoT application. This is BINDU SWETHA, working as an assistant professor in the Department of ECE at Pullaiah College of Engineering and Technology, Kurnool, Andhra Pradesh, India. Before going to start the session, I would like to say one point. My deepest gratitude goes to all my teachers, gurus, parents, Almighty, for giving me the sense that God is permitting me to share some of the views related to the topic of interest. I guess, in my point of view, any topic that is related to life, in fact, can't be judged without one perspective, right? We have different scenarios and perspective related to life. Today's agenda. What is IoT? What is the history behind this particular IoT? Need for IoT, importance of IoT, recent developments in IoT, computing in IoT, signal processing in IoT applications, importance of signal processing in IoT applications, benefits of adapting computing and signal processing in IoT, and last move on to fields in which IoT has a wide range of opportunities. Yes? Yeah. What is IoT? IoT stands for Internet of Things. Yes, Internet connects all the people. Right now, we are connecting through the Internet. It is called as Internet of People. If Internet connects all the things, so it is called as Internet of Things. Internet connects everywhere. in this world, but it is a still connection between person to person, or a person to thing, or sometimes things to thing. So Internet of Things is a platform where regular devices are connected to the internet, so they can interact, collaborate, exchange data with each other. We still have the discussion to do things for us before IoT existing right now. Before IoT, the difference is that you have to run, person have to run from one machine to the another machine, telling them what to do for you. That means what? Person, human has to do the work to that particular device. That means devices can interact, collaborate, and learn from each other. This is ultimately the aim to reduce human interventions in a machine cycle. The machines here continuously touch with each other and could be pre-instructed what to do and when to do further. Now, let us find IoT what actually means. The term IoT has two keywords. Number one is things, Internet of Things, things and internet. Internet, as well as it is known as a network of networks, the medium through which a device connect. The thing could literally be any object with intelligence to connect the internet. Of course, by an object, aim talking about object embedded with software called electronics. These things could refer to the way more than your traditional devices like let us say desktop or PCs or laptops, maybe smartphones or any electronic gadgets. So IoT is a platform where your devices are connected to the internet, so they can interact, collaborate, and exchange data with one another. The World Wide Web, simply called web, which is the only way to access and share the information that is available on the internet. Internet is the huge network that connects various devices globally. Any device can communicate with other devices as long as they are connected to the internet. So the web is the basically only way to access documents that are existing in the internet space. IoT connecting everyday things embedded with electronics, software, sensors to the internet, enabling them to collect and exchange data. IoT refers to physical and virtual objects that have unique identities and are connected to the internet. That allows the development of intelligent applications, which makes energy, logistics, industrial control, and whatnot. Other domains of human endeavor, that like smarter or intelligent. Yeah, move on to history of IoT. The man, Kevin Ashton coins the term IoT and establishes MIT's Auto ID Center, a global research network of academic laboratories focused on RFID and IoT. So you get the stuff, smart water bottle, etc. This stuff is not IoT. This stuff is all rubbish. Previously, he believed that IoT could turn the world into data in the year 1999 that could be used to make micro decisions on resource utilization. Information is a great way to reduce waste and increase efficiency, and that's really what IoT provides. Right? Information is a great way to reduce waste and increase efficiency, and which really what the Internet of Things provide. Yeah, recent developments in IoT. The ultimate goal of IoT is to automate humans' life. The main ultimate goal of this IoT is to automate humans' life. Consider any application of IoT. Just you name it, and I assure that you will have it in IoT. How much more IoT can do is only left to your imaginations. Hence, the internet is currently a human to human affair, but this is changing. Maybe a person to thing, or person to device, or device to device. Recent developments in IoT. Healthcare system, consider healthcare system, or fitness, or IoT cloud development, or big data, artificial intelligence, maybe emergence of IoT ecosystem, implementation of IoT into marketing, and many more. Consider Google Waymo, which is the perfect example of what IoT has in store for us in coming future. Machine learning, artificial intelligence, involvement, and computing analysis or edge computing analytics all come into play to make the car or to make any device, smart device, operate and analyze the environment in real time. Now, with the changing time, the company has introduced further new cars into the market. As expected, the software side includes wide arrays of complex algorithms for the entire process to work. I believe we live in the world where technology is rapidly taking over our lives. Like literally, getting up in the morning, we have our handheld devices at disposal, helping us, guiding us, informing us about our new and upgraded lives. So daily we are updating and upgrading ourselves. The internet has made the connectivity and seamless across various platforms. The idea of world becoming a global village has in actually been achieved. A huge contribution of these advancements goes to the rapid developments in IoT sector. General population is becoming more technology is necessary for these adaptation. For example, consider mobile applications as well as virtual aspirants like Alexa, Amazon Alexa, or Google Speaker are becoming more common and widely used in everyday routines. We have been smart cars completely. We are having even smart cars coming up which can store and transmit your medical information on the go. With IoT and cloud computing models, you basically push and process your scenarios data in the cloud. You have an investigation modules that takes in data and stores it in a data lake, let us say large storage, and you can apply parallel processing over it. So it could be Spark, maybe Azure, HD Insight, Hive, etc. That means the technology supporting IoT is growing at fast pace. No wonder they have become a part of our daily lives. Let us consider the latest developments by using IoT which are taking place in the IoT sector and how they will facilitate us in the time to come. Computing in IoT. Common computings like cloud computing, fog computing, edge computing, mixed computing, like that. Cloud computing. The term is generally used to describe data center available to many users over the internet. The practice of using a network of remote servers hosted on the internet to store, manage, and process the data rather than a local server or a personal computer. It is the delivery of different services through the internet. Without internet, we can't able to do any work. These resources include tools, applications like data storage, servers, databases, networking, and softwares. As long as an electronic device has access to the web, it has the access to a data and software programs to run it. It involves delivering different types of services over the internet, from software and analytics to secure and save the data storage and networking resources. Everything can be delivered via the cloud. What are the benefits? Flexibility of work practices. That means you can access or you have the ability to access the data from your home. There is no need to go here and there on holiday or via the commute to and from work, providing you have an internet access, you have an internet connection. For example, consider Google Drive. Is Google Drive a cloud? Yeah, Google Drive is a personal cloud storage. Yeah, it is a personal cloud storage service from Google that lets users stores and synchronize digital connect across the computers or laptops or mobiles or any electronic gadgets. It is like again maybe public cloud, private cloud, hybrid cloud, community cloud, and many more. So depends on application that particular cloud may come into companies. So they need to buy some sort of bugs. For example, AWS, Amazon Web Services, right? Does Amazon uses cloud computing? Amazon uses cloud computing, AWS. AWS is comprehensive, evolving cloud computing provided by Amazon, which includes a mixture of infrastructures as a service, that means IaaS, platform as a service, PaaS, and packaged service as a service, SaaS offerings. Now, move on to edge computing. Edge computing is a distributed computing paradigm that brings computation and data storage closer to the location where it is needed to enhance or to improve the response time and save the bandwidth and reduces the wastage. It is a distributed open IT in architecture which features decentralized processing power, enabling mobile computing and IoT technologies. In this, data is processed by the device or by a local computer or a server rather than being transmitted to the data center. Why do we need edge computing? What is the necessary? The most important benefit of this is its ability to enhance or its ability to increase network performances by reducing the latency. By processing data closer to the source, reducing the physical distance it must travel. Edge computing can greatly reduce latency. What is edge computing and why it matters? It allows for more efficient machine learning by distributing the processing load to the sensors and other edge services. The data must be sent to not only sending and the same time retrieving, not only transmitting, at the same time retrieving from the cloud can be summarized or coded by the local devices, which is allow for much smaller packages to be sent over the cloud. This platform enables developers to develop and manage IoT computing applications. For example, can be increasingly found aroses. Smart street lights, automated industrial machines, mobile devices, smart parking, and many more. IoT and computing are related because it addresses IoT challenges such as network connections, latency. It is a placement of compute, storage, networking resources outside of network core and closer to the end users. It optimizes internet devices, web applications by bringing computing closer to the source of data. This reduces the need for long distance communication between client and server, which again in turn reduces latency and bandwidth usage. Move on to fog computing. Fog computing allows computing, decision making, and action taking to happen via IoT devices and only pushes relevant data to the cloud. Cisco coined the term fog computing, gave a brilliant definition for fog computing. The fog computing extends cloud to be closer to the things that provide or that produces and acts as a IoT data. Fog computing helps to create low latency network connections between devices and their analytics. Their architecture in turn reduces the amount of bandwidth needed when compared to the cloud. It can also be used in scenarios where there is no bandwidth connection needed to transfer the data. It works by deploying fog nodes throughout your network. Devices from controllers, switches, routers, and video cameras, surveillance cameras can act as a fog nodes. These fog nodes can then be deployed in target areas such as your offices, like your home, your workplaces, within a vehicle. So what is the advantage of this particular computing? Latency reduction. That means reduced latency. The primary benefit of this is data does not necessarily needed to be sent to the cloud. Cloud and disk computing both offer end users data, storage, computation, and application services. But for computing is much closer proximity to the end users and better supports mobility. To be precise and to be clear, it will not replace cloud computing altogether. Rather, it's a supplement to the cloud. In short, or one line summary, surrounding mobiles computing are a number of challenges. Ratio characteristics are inherently poor. Mobility implies address migration, location dependency, and portability implies limitations on physical device characteristics. Limitations like not always connected to, maybe not always connected with enough bandwidth. Cloud computing centralized analytics, security point of view, like security shortcomings. I believe, in my point of view, by 2030, the number of things that are part of IoT may reach up to 80 billions. That a lot of data being generated. Tech giants, MNC companies like Cisco, IBM, and other are the driving forces behind computing and their concepts to emerging IoT. According to Cisco, the important areas are where computing would play a vital role. IoT and computing integration is referred to as Cloud of Things, COT, Cloud of Things. IoT and cloud computing integration is not that simple and it has some key issues. Think globally, act locally by Paul McCartney. Move on to mixed computing. It is the extreme edge of a network, typically consisting of microcontrollers, services, sensors. Mixed computing uses microcontrollers, microprocessors to feed into fog computing nodes and potentially onwards towards centralized computing services. That means cloud. Simply consider water vapor that condenses high in the atmosphere is called as a cloud. Basically, water vapor that condenses close to the earth's surface is called fog or mist. Ultimately, timing is a key. Amazon HTTP delay 1 second. Amazon HTTP delay 1 second. 1 second is equal to 30 rotations. Amazon HTTP delay is 1 second. 1 second is equal to 30 rotation. Yeah, move on to next slide. Computings. Yeah, fog computing, edge computing, cloud computing, how the data centers. Next one is signal processing in IoT. Signal processing. Basically, signal processing is a collection of methodology and algorithms that we can use to processing and recover the information to learn new things about the things which are presented to us. Signal processing is a branch of electrical engineering which pulls meaning from the sources of data all around us. To me, signal processing is really about making the info which is very useful. The devices that we use, that we interacting in a daily basis have so many sensor stuff really required signal processing. Signal processing has applications in many different scientific and engineering field like image processing, speech processing, audio, video, communication, internet traffic analysis. It has a huge impact in national defense, security, in medicines, and how we diagnose diseases and how we treat diseases or how we navigate the world, how we find people and make friendship and connections. Signal processing opens the IoT to a new world of possibilities. Research leads to new Internet of Things by using some various technologies like wireless or wired technology and its applications. You really have the opportunity to find what companies use most and apply signals processing to that, because there is no arm of tech that doesn't use. I find signal processing really exciting because it gives me a way to connect really elegant mathematical models to practical problems and its applications. Not only mathematical models, we need to go with in-depth knowledge with many or with various applications. All different regions of brain interact with each other and how they affect the outcome of it. So there is a damage part of the brain. For example, consider our brain. If there is any damage part, how that will affect center, how that will affect certain amount of functions. Application focusing on right now have to do with generating analysis signal faster rates when traditionally done. I believe the signal processing and DSP, digital signal processing, today is rather mature discipline. It is very well established. Signal processing is a discipline that expands and intertwines with so many disciplines. All the time, there are always new challenges. Consider medical field. Signal processing in MRIs. Consider medical field. Signal processing in MRIs. Advancements in medical imaging allow to study parts of the body including the brain like never before, but now over the MRI images formed invasively without radiation, short answers by relying on the signal processing. The science behind our digital life, the science behind our digital life. DSP, digital signal processing, is more than just ADCs and its algorithm. That means analog to digital converters and its algorithm. Moving processing closer to the peripherals can enhance performance and power usages. DSP brings digital signal processors to the mind. DSP algorithms need input and output, so they tend to be surrounded by ADCs, that means analog to digital converters, and digital to analog converters, both ADC as well as DAC. Other than that, microcontroller often handle DSP's cores and often include DSP's instruction. Microcontroller uses ADCs and DACs on the microchip. Currently, the trend in microcontrollers is to allow peripherals to operate and when the processor is in one or more sleep modes, which reduces power requirement as the peripheral controller uses much less than processing core. Many sensors can use significantly less power if the processing is significantly less power if the processor only runs when sufficient data has been obtained. What are the benefits of adaptive computing and signal processing? Signal processing is an engineering subfield that focuses on analysis, modifying, and synthesizing signals such as sound, images, and scientific measurement. Adaptive signal processing extension. If you go more into that particular signal processing, we'll find adaptive signal processing. In practice, most systems are inherently time varying and non-linear. The signals associated with these systems often have time varying characteristics. In my point of view, adaptive signal processing is a branch of statistical signal processing. That means more mathematical models are involved with various applications, which deals with challenging problems of estimation and tracking of time varying systems by virtue and its applicability to time varying and nonlinear systems. Adaptive signal processing finds applications in a broad range of practical fields such as telecommunication, radar, and signal processing, biomedical engineering, and whatnot, maybe entertainment systems, and many more examples. Adaptive signal processing has many points of similarity to adaptive control. These are, however, many important differences in emphasis, leading to differences in algorithms in the analysis. The points like in adaptive control, complete signal processing, we have measurements of both input and output of plants. In this particular plant, which is a signal model whose input is unknown. That means raw data. That raw data has to be, raw data means what? Unprocessed data. That has to be converted into processed data, then given to the plant. In control applications, the plant is often stable and minimum phase. The models encountered in signal processing have poles nearer on the unit circle and are often non-minimum phase. In adaptive filters, it is often necessary to impose various constraints on the filter parameters. That means linear phase, characteristics, equitable, passband, etc. Those constraints complicate the clarivative completely analysis of the adaptive algorithms. In these signal processing problems, the measurements are often extremely noisy. We need to reduce that particular noise and capture the exact image or capture exact audio or capture exact signals with no delay and no noise. Systems are usually designed to provide relatively noise-free information. It is also possible for partial update adaptive filters to achieve performance improvements at reduced complexity. In well-established methods of adaptive signal processing, theory are modified and extended in order to address some of the basic issues of adaptive control and adaptive inverse modeling. Process can be used to obtain a stable controller whether the plant is minimum or non-minimum phase. No direct feedback is involved. There is no direct feedback is involved in the system. The output is monitored and utilized or observed in order to adjust the parameters of the controller. This method performs very well in computer simulations of a wide range of stable plants, and it seems to be a promising alternative approximation to the design of adaptive control system. Foundation of cognitive radar. Currently, research is going on in this particular field, cognitive radar, for next generation radar system. And hence, signal processing, that means the science behind our digital life, according to IEEE Signal Processing Society. Signal processing, the science behind our digital life. Signal processing is everywhere, embedded in the technology around us. Stay tuned to this particular signal processing impact and involvement in our everyday life. Then what is the importance? Why people are moving toward this signal processing domain in the IoT system? What is the significance or what is the important? Audio and image signal processing is a more efficient way to monitor asset health and perform preventive maintenance. Audio signal processing monitor the sounds that equipment makes, triggering alerts when a machine is making noises outside the normal range. So we need to capture and we need to control all the parameters. Applications, various applications like DSP applications, which includes audio and speech processing, radar and other sensor array processing, let us say statistical signal processing, or else digital image processing, data compression, video coding, audio coding, image compression, advanced digital system design, big control systems, or else telecommunication and whatnot. Many areas, many applications. So signal processing is significant and which is very essential because it significantly increases or enhances the overall value of hearing protection if you are considering with Speech processing, hearing protection. Signals are converted into a domain where abstract scientific and mathematical models are then applied. Not only mathematical models, but also analysis has to be done. Hence, the result is a powerful processing system. Yeah, finally move on to fields in which IoT has a wide range of opportunities. Basically, IoT has many applications. Basically, IoT has many applications like home automations. Internet of Things has many applications like home automation, smart city, smart environment, energy, retailing, logistics, agriculture, industry, healthcare, lifestyle, fitness, and many more. That means what? If you are considering this uh, smart home means what? We can say like a smart lighting, intrusion detections, smoke. For example, consider smart city like smart parking, smart roads in that particular area, like structural health monitoring, emergency responses. For example, consider environment, weather monitoring, air pollution monitoring, noise pollution monitoring, forest fire detection. Consider energy, smart grids, renewable energy sources. Consider retailing, inventory management, smart payment, smart vending machines. Consider logistic area, route generation, scheduling, tracking, shipment monitoring, remote vehicle diagnostics. Consider farming, agriculture, smart irrigation, greenhouse control, industry, IIoT, industrial IoT, machine diagnosis and prognosis, indoor air quality monitoring. Consider most and promising area, health and fitness, health and lifestyle, health and fitness monitoring by using wearable electronics. That means the application of IoT networks extract and create information from lower level data by filtering, processing, categorizing, condensing, contextualizing the data. This information obtained is then organized and structured to infer knowledge about the data. Complete system. For example, consider security challenges. From unsecured devices to secure devices. For example, consider any network. A network can block unwanted traffic, detect suspicious behavior, and it has to flow wanted traffic. For example, consider network challenges, scalability, diversity, open network interface, low power communications. If you are observing the word low power, means what? People are going that, but the technology is going day by day rapidly. That means what? The device is going to optimize in that low power consumption, low power communication. At the same time, size of the device is going to reduce and power utilization is going to reduce. Other than that, software development challenges. Consider big data. Let us say volume, variety, velocity. We can able to capture the data, analyze the data, visualize the data. Self configuration. That means software, hardware, networking, etc. New and complex dependencies, modeling human behavior, human in the loop. That means what? Now people are working on human, how people are thinking by using IoT. New and complex dependency. Consider home automation. Consider by using IoT home automation. That means what? Security challenges. Unsecure devices to secure devices. That means if you are working in home, from home only, I need to go with security challenges. Smart lighting. For home helps in saving energy by adapting lighting to the ambient conditions and switching on or off or dimming the lights when needed. Key enabling technologies for smart lighting include solid state lightings by using LEDs concept and IP enabled lights, that means internet protocols. A solid state lighting model is described and implemented on a wireless sensor network that provides services for sensing illumination changes and dynamically adjusting luminary brightness according to user preferences. Consider security challenges means what? Consider smart applications. Modern homes have a number of applications such as uh, TVs, refrigerator, music system. Network can block unwanted thing. Managing and controlling these appliances can be cumbersome, and with each appliance having its own controls or remote controls. Smart appliances make the engagement easier and also provide stated information to the users remotely.
Hello? Hello? Ma'am, are you there? Hello? Ma'am, please turn on your audio, ma'am. Hello, ma'am. Am I audible? Can you hear me? Hello?
Yeah, ma'am.
Yeah, you can hear me, ma'am?
Yes, I can hear you.
Yeah, okay. So, yes, ma'am. You may turn on your, video now.
Okay.
So, thank you for the very informative presentation, ma'am.
Thank you
And
so much.
yeah, and I thank you especially and also all our attendees today for joining us in a live session. For all queries and questions, you can write us via webinar at IFERP.in. I'd also like to extend my thanks to our academic partner, United Innovators. Do check out unitedinnovator.com for help with research article writing, patent filing, publication, and also PhD assistance. So, thank you very much, ma'am, for joining today.
Thank you so much.
Yeah, have a good day, ma'am. Have a good day, all
Thank
of you.
you.
Yeah,
Thank you, all of you.
yeah. Bye, ma'am.
Bye.